Module 2: Advanced Welding Processes and Techniques. Hello folks, welcome to Module 2 of this course and the comprehensive lecture on Advanced Welding Processes and Techniques. Gas tungsten arc welding GTAW. Gas tungsten arc welding, commonly referred to as GTAW or TIG welding, is a precision arc welding process that employs a non-consumable tungsten electrode to produce the weld. This lesson will guide you through the fundamentals of the GTAW process, equipment setup and operation, advanced welding techniques, and essential safety considerations. GTAW process fundamentals. The GTAW process uses an arc struck between a non-consumable tungsten electrode and the workpiece to create the weld. Here are the key components. Tungsten electrode, the core component of the GTAW process, known for its high melting point and conductivity. Inert shielding gas, typically argon or helium, used to protect the weld area from atmospheric contamination. Power supply provides the necessary current and voltage to initiate and maintain the arc. GTAW is renowned for producing high-quality welds requiring minimal post-weld cleanup due to its clean, precise nature. It is most commonly used for welding thin sections of stainless steel and non-ferrous metals such as aluminum, magnesium, and copper alloys. Benefits of GTAW. Precision allows for tight control over the welding process, resulting in superior weld quality. Versatility, effective for welding a wide range of metals and thicknesses. Clean welds, produces welds with minimal spatter and slag. Equipment setup and operation. Proper setup and operation of equipment are critical for successful GTAW. Let's explore the primary components and steps involved. Essential equipment. Welding power source, available in both AC and DC variants depending on the material being welded. Torch, holds the tungsten electrode and provides cooling. Shielding gas regulator, controls the flow rate of the gas to ensure optimal protection. Filler rods, used to add material to the joint when necessary. Steps to set up. Select the correct electrode. Match the electrode to the material and type of current AC, DC. Adjust the welding parameters. Set the appropriate amperage based on the metal thickness and type. Secure the workpiece. Ensure the workpiece is clean and firmly clamped to avoid movement during welding. Set the gas flow rate, typically around 1.5 to OCFH cubic feet per hour for argon gas. Advanced welding techniques and safety. As you gain proficiency in basic GTAW operations, exploring advanced techniques can significantly enhance your welding skills. Pulse GTAW. Utilizing pulsed current allows for better control of heat input, especially beneficial for thin materials. This technique involves cycling between a high peak current and a low background current, reducing the risk of burn-through. Walking the cup. This technique enhances stability and precision, particularly in pipe welding. It involves resting the cup of the torch on the workpiece while rolling it forward in small increments during welding. Back purging. Essential for stainless steel welding, back purging involves applying inert gas to the reverse side of the weld to prevent oxidation, ensuring pristine weld quality. Safety considerations. Your safety is paramount. Adhering to these safety guidelines will protect you and those around you. Personal protective equipment (PPE). Welding helmet. Offers protection against harmful UV and infrared rays. Choose helmets with appropriate shading levels. Gloves and protective clothing. Flame-resistant gloves and clothing prevent burns and other injuries. Safety glasses worn under the helmet to safeguard against flying debris. Ventilation. Ensure adequate ventilation in the welding area to mitigate exposure to harmful fumes and gases produced during the welding process. Electrical safety. Maintain dry hands and equipment to avoid electric shocks. Regularly inspect cables and connectors for wear and tear. Executive summary. Here's a summary of gas tungsten arc welding GTAW. What is GTAW? Gas tungsten arc welding GTAW also known as tungsten inert gas TIG welding, is a welding process that uses a non-consumable tungsten electrode to produce an electric arc. The arc is shielded by an inert gas such as argon or helium to protect the weld area from atmospheric gases. Principle: GTAW uses an electrical arc to melt and join metals, with the tungsten electrode being held in a torch and shielded by an inert gas. The arc is maintained by a constant current power source, and the weld pool is protected from atmospheric gases by the shielding gas. Equipment: 1. Power source. A constant current power source is used to generate the electrical arc. 2. Torch. A torch is used to hold the tungsten electrode and shielding gas nozzle. 3. Tungsten electrode. A non-consumable tungsten electrode is used to produce the electrical arc. 4. Shielding gas. An inert gas, such as argon or helium, is used to shield the weld area from atmospheric gases. Process variables. 1. Current. Controls the heat input and penetration of the weld. 2. Voltage. Controls the arc length and stability. 3. Shielding gas flow. Controls the amount of shielding gas used to protect the weld area. 4. Torch angle. Controls the direction of the arc and the weld pool. Advantages: 1. High-quality welds. GTAW produces high-quality welds with minimal porosity and lack of fusion. 2. Low distortion. GTAW produces minimal distortion due to the precise control of heat input. 3. Versatility. GTAW can be used to weld a wide range of metals, including aluminum, stainless steel, and titanium. Disadvantages: 1. Slow process. GTAW is a slow process compared to other welding processes. 2. High skill level required. GTAW requires a high level of skill and technique to produce high-quality welds. 3. Expensive equipment. GTAW equipment is more expensive than other welding processes. Applications: 1. Aerospace industry. GTAW is widely used in the aerospace industry for welding critical components such as engine parts and airframe structures. 2. Automotive industry. GTAW is used in the automotive industry for welding high-performance components such as exhaust systems and engine parts. 3. Chemical industry. GTAW is used in the chemical industry for welding corrosion-resistant components such as pipes and vessels. Here's a summary of the equipment setup and operation for gas tungsten arc welding GTAW. Equipment setup. 1. Power source. Connect the power source to a suitable electrical outlet, ensuring the voltage and amperage match the GTAW process requirements. 2. Torch. Connect the torch to the power source, ensuring proper electrical connections and shielding gas flow. 3. Tungsten electrode. Install the tungsten electrode in the torch, ensuring proper seating and alignment. 4. Shielding gas. Connect the shielding gas cylinder to the torch, ensuring proper gas flow and pressure settings. 5. Workpiece. Securely fasten the workpiece to a welding table or workbench, using clamps or vices as necessary. Operation. 1. Pre-welding checks. Verify the equipment is in good working condition and the workpiece is properly prepared. 2. Setting current and voltage. Adjust the current and voltage to match the desired welding parameters. 3. Setting shielding gas flow. Adjust the shielding gas flow to match the desired gas coverage and weld quality. 4. Striking the arc. Hold the torch at a 10 to 20 angle, lightly touching the tungsten electrode to the workpiece, and strike the arc by quickly moving the torch away. 5. Maintaining the arc. Adjust the torch angle, travel speed, and current to maintain a stable, consistent arc. 6. Welding technique. Employ proper welding techniques such as forehand or backhand to achieve desired weld quality and penetration. 7. Post-welding procedures. Allow the weld to cool, inspect for defects, and perform any necessary post-welding operations such as grinding or cleaning. Safety considerations. 1. Electrical safety: ensure proper electrical connections, avoid overloading, and use electrical insulation as necessary. 2. Fire safety: keep the work area clean, remove flammable materials, and have a fire extinguisher nearby. 3. Personal protective equipment: wear proper PPE, including a welding helmet, gloves, and safety glasses to prevent injury. 4. Ventilation: ensure adequate ventilation to prevent inhalation of fumes and particles. 5. Regular maintenance: regularly inspect and maintain equipment to prevent accidents and ensure optimal performance. Best practices: 1. Regularly clean and maintain equipment. Regularly clean and maintain equipment to prevent contamination and ensure optimal performance. 2. Use proper shielding gas. Use proper shielding gas to protect the weld area from atmospheric gases and ensure optimal weld quality. 3. Monitor welding parameters. Monitor welding parameters such as current and voltage to ensure optimal weld quality and penetration. Here's an overview of advanced welding techniques and safety considerations for gas tungsten arc welding GTAW. Advanced welding techniques. 1. Pulse welding, a technique that involves pulsing the welding current to improve penetration and reduce heat input. 2. Weave welding, a technique that involves moving the torch in a weaving motion to improve weld penetration and reduce porosity. 3. Push angle welding, a technique that involves pushing the torch at an angle to improve weld penetration and reduce heat input. 4. Hot wire GTAW, a technique that involves using a hot wire to preheat the workpiece and improve weld penetration. 5. Orbital GTAW, a technique that involves using a rotating torch to weld pipes and tubes. Safety considerations. 1. Electrical shock: ensure proper electrical connections and insulation to prevent electrical shock. 2. Eye damage: wear proper eye protection, including a welding helmet and safety glasses to prevent eye damage from UV radiation and sparks. 3. Fire and burns: keep the work area clean and free of flammable materials, and wear fire-resistant clothing to prevent burns. 4. Fume inhalation: ensure adequate ventilation and wear a respirator to prevent inhalation of welding fumes. 5. Physical strains: take regular breaks and use proper ergonomics to prevent physical strains and injuries. Specialized safety equipment. 1. Welding helmet with shade 10 to 14 provides proper eye protection from UV radiation and sparks. 2. Fire-resistant clothing provides protection from burns and fires. 3. Respirator provides protection from inhalation of welding fumes. 4. Insulated gloves provides protection from electrical shock and heat. 5. Safety glasses provides additional eye protection from sparks and debris. Best practices. 1. Regular maintenance: regularly inspect and maintain equipment to prevent accidents and ensure optimal performance. 2. Proper training: ensure proper training and certification before performing advanced GTAW techniques. 3. Follow safety protocols: follow established safety protocols and guidelines to prevent accidents and ensure a safe working environment. 4. Monitor welding parameters: monitor welding parameters such as current and voltage to ensure optimal weld quality and penetration. 5. Use proper shielding gas: use proper shielding gas to protect the weld area from atmospheric gases and ensure optimal weld quality. Conclusion: mastering gas tungsten arc welding opens numerous possibilities in metal fabrication, allowing for the creation of strong, precise, and aesthetically pleasing welds. Remember to prioritize safety, continually refine your techniques, and adapt to different materials and conditions. Thank you for participating in this lesson on gas tungsten arc welding. We hope you found it informative and engaging. Keep practicing to enhance your skills and achieve mastery in GTAW. Happy learning, folks!